Real exam, real questions. Today we crack 9709 Pure Mathematics 1 Quadratics wide open, step by step, the way examiners want. Let's get your exam ready. This is Global Math Mentor. All right, pause here for a moment and take a look. This is exactly what the syllabus says you need to know for quadratics. Save it if you want, because everything we do today is built on this. Problem 1. This is from March 25, question paper 1-2, A-level Mathematics 9709. Okay, so curve has the equation y equals to 5 plus 3x minus 2x squared. And the straight line has the equation y equals to kx plus 13, where k is a constant. Find the set of values of k for which the curve and the line do not meet. So this question is related to the concept of discriminant, where you need to first get rid of these two equations. How do you do that? Substitute the linear equation and into the nonlinear equation, which is the curve. So this will become kx plus 13 equals to 5 plus 3x minus 2x squared. Now I need to standardize it. Why? Because I need to go with the discriminant and put that discriminant less than 0 because the line and the curve do not intersect. So let's add 2x squared, subtract 3x, and subtract a 5 and plus kx plus 13 and put it equal to 0. This will be 2x squared. Okay, this is the tricky part. Make sure you are getting my point. There's a term in x, which is kx, and there's another term in x, which is a minus 3x. So how do you make them one? You can factorize the x out like this, and plus 13 minus a 5 is going to be 8. Now this is a standard quadratic equation. Why are we standardizing it? Because we need to apply the discriminant. Now, since line and the curve, this is a quadratic curve. Oh, okay. By the way, it was like this, and there's a line. Uh, they do not intersect. So I need to find the set of values of k. Let's apply the discriminant. So b squared minus a 4ac and put it less than 0. This will be k squared, again standardizing, minus 6k plus 9 minus 64 and less than 0. This will be k squared minus 6k, and this is going to be minus 55 less than 0. This now is a quadratic inequality. So, as I was showing you earlier, the specs of the syllabus. So quadratic inequality is part of the structure of questions. Discriminant is part of the syllabus. Equating line and a curve, like solving or, maneuvering a pair of system where one of the equation is a linear one and the other is a quadratic one. So let's now middle term break this, factorize it. So 11k plus 5k and minus 55 less than 0. It's a factorizable one, but even if it's not a factorizable one, you can use quadratic formula to get the roots, because in solving the quadratic inequality, all I need is the roots of the quadratic equation. So I can sketch it and find my desired region. K minus 11 and k plus a 5 less than 0. Let's sketch the parabola like this. And this is a negative 5, and this is 11. So what part of the graph is below the x-axis? Why am I saying below the x-axis? Because it's less than 0. Your y value, your function value is less than 0. So this is the part which I need to shade, and k will be within 11 and minus 5. That is my answer. If you have any difficulties like solving quadratic inequality, I'll share a link in the description. There's a whole video I did on quadratic inequalities, and there's one on the solving a linear and a quadratic system. And there is much more that I have solved on my channel related to discriminants. So make sure, if you get some difficulty or like you struggle while solving these questions, you can go back and watch the basic concepts again. Let's move on to the next problem. Here is another problem from Winter 23, question paper 1-3, and this is question 6 on this exam. A line has the equation y equals to 6x minus c. And the curve has the equation y equals to cx squared plus 2x minus 3. So it looks like a similar question as compared to the previous one, where c is a constant. Well, let's see the condition. The line is a tangent to the curve at point P. Find the possible values of c and the corresponding coordinates of P. So the change is that this time your line is tangent to the curve. So whatever the situation is, maybe the parabola can be downward opening or upward opening, but whenever the line is tangent, it means there is only one point. So the value of the discriminant is going to be equal to 0. Okay? So let's substitute them, put them equal. 6x minus c equals to cx squared plus 2x minus 3. And this will be, if I standardize it, it's going to be negative 4x plus a c minus a 3 and put it equal to 0. Well, you can always pause and try to, you know, do it yourself as well. This will be a good way to learn. Okay, so now I apply the discriminant, which is b squared minus 4ac, c minus 3, and put it equal to, oh, my bad, c was a, yeah, c minus 3, and put it equal to 0. This is 16 minus 4c squared plus a 12c, and put it equal to 0. I like to keep my leading coefficient positive, so I'm going to write it this way. Like you can time both sides with a negative sign. 4, if you factor it out, c squared minus 4, 3c minus 4 and equal to 0. So divide both sides by 4. This goes away. C squared minus 4c plus c minus 4 equals to 0. Often students ask me like, do you really need to show the factoring or something? I mean, if you apply the quadratic formula, you can maybe show the steps. Maybe a single step might work, because if it's not a B mark, remember, then if it's M mark instead, so you will be judged on the on basis of some suitable method that you have used. So directly writing it with the help of the calculator, I mean, you can always check the mark schemes and you can see whether the method mark is there or the independent mark is there. C plus 1. If you do not know what is a method mark or independent mark, you can maybe put a comment there and I can answer you later, right? C equals to minus 1 and C equals to 4. So these are the two C values. And I was required to, usually, I mean, most of the time the question ends here, but they are saying this time, find the possible values of C and the corresponding values of the coordinates of P. So what are the X and the Y coordinates of P, corresponding coordinates of P? So I can check each case individually when c equals to negative 1. Okay, now this is the thing, like you don't need to again put these back into the given equations and then set up the equation again, equating them. You can just consider this equation. Why this equation? Let me tell you. This is the equation that we got by equating the line and the curve. So just use this one. So this is a good one, this equation. So if I put minus 1, it's going to be minus x squared minus 4x and minus 4 equals to 0. So all of the values, if I time it with the positive, I usually like keeping the leading coefficient positive, I told you earlier, but okay, so x becomes a minus 2. So what will be the y value then? I can use this linear equation over here, but I need to sub in the x value and the c values as well. So c times a negative 2 and minus a minus 1, right? So it doesn't matter. You can even use a non-linear, like the curve, to get the value of the y coordinate. So this is minus 12 plus, so it's a negative 12 and plus 1, so negative 11. So minus 2 and minus 11 is one of the possible coordinate of P, coordinates of P. Okay, when I can quickly check the second situation as well, c equals to 4. So my equation becomes 4x squared minus 4x plus 1 equals to 0, which is a perfect square. Again, why are we getting perfect square? You can check them any way you want to, because these c values will produce, it's tangent to the curve, so it will produce repeated roots. So repeated root equation looks like this. They are whole squares, like perfect squares. X equals to 1 over 2. Okay, so the y value is going to be 6 times the 1/2 and minus a 4. So 2, 3. This is a minus 1. So another possibility is half and a minus 1. That's it. This one is from summer 24, question paper 1 and question 1 on that exam. Let's do the first part. Express 3y squared minus 12y minus 15 as this. So this is the completing the square form or the vertex form of this quadratic expression. So how do you do this? There are many ways you can do this, but the classical one is just factor out the 3. This becomes y squared minus a 4y. I mean, you can factor out 3 from the 15, but you can just leave it on the side. So this will be 3 and y squared minus 4y plus 2 squared minus 2 squared and minus 15. You're trying to complete the square. This will be 3 y minus 2 squared minus 4 and 3 minus 12 and minus 15. So the answer is going to be, final answer is going to be 3 y minus 2 squared and minus 27. Whichever way you have learned, this is going to be your final answer, right? Okay, they are saying hence find the exact solutions of the equation this. Now, when they say hence, it means you have to use your previous part. So now I'm going to use my previous part, and there is another change. You can see that all my y's are now x's, but the y is being switched with x squared. So I can use the previous form, but instead of y, I can substitute 3x squared, 2 squared minus 27. I hope you get the idea. So this is the equation in which in place of y, I have x squared now, and in place of y squared, I have x to the power of 4. So if you square these, you will see what do I mean by that. Y squared is going to be x4. Okay. So now how do you solve it? Using completing the square form to solve a quadratic polynomial. Obviously, it's the fourth degree equation, but it can be modeled. There are other ways of solving this equation as well. Like I can suppose x squared to be, let's say, a, and then my equation will become 3a squared minus 12a and minus 15. But that is not the hence part. If they say hence or otherwise, then you can use whichever method suits you, right? Okay, so divide both side by 3. So this will be 9x squared minus 2 whole square. If you square root both sides, this will become x squared minus 2 equals to plus minus 3. So x squared equals to 2 plus minus 3. So one of the answers is going to be x squared 2 plus 3 and x squared 2 minus 3. This becomes x squared equals to minus 1, which is not applicable since this is an imaginary solution. And this value over here will become x squared equals to 5. So this implies that x is a plus minus root 5. So this one is from summer 22, question paper 1, 2, and question 5 on that exam. The equation of the curve is given, and the equation of the line is given, where k and r are constants. Given that the curve and the line intersect, so they do intersect at the points with the x coordinate, this and this. Find the values of k and a. So this seems like the system which has the equation, but there are some unknowns inside the line and the curve. So first we can equate the line and the curve and see what we can do about how to get these values, k squared and equals to x minus a. So this will imply that if I standardize it, minus kx and minus x plus a 1/2 k squared plus a and equals to 0. So your usual subtracting and adding on both sides. And from here, I can write this thing as, watch out for this step, the one which I'm going to do. Take out the negative, put a k plus 1 and the x. So that the negative bracket k plus 1, you might be thinking, like, can I leave it like minus k minus 1? That's fine as well. So plus a 1/2, and all of this is a constant. How to approach this problem? If I go with a discriminant, I will have more than one unknown. So that won't be a nice inequality to solve. So let's try something else. Since we have the solutions satisfy the equation, right? So sub in, like you can sub or substitute or put x equals to 0. This will give you half k squared plus a equals to 0. Let's call this equation 1. Okay, where did the x's go? They are all 0 now. When you sub x equals to a 3/4, this will look like, okay, so 4 times, okay, let me write 9 over 16 minus k plus 1 times a 3/4 and plus a half k squared plus a equals to 0. Now, you got to be careful with these questions. Like, you can see that all of this is 0. Have you noticed? Like, this part is 0. So I know that if I substitute this in the second equation, so you can guess that this part is just a 0. You get it? So now I can write 9 over 4 minus a 3/4 and k plus 1. This will easily give me the value of k. Let's just do the normal calculations. 3, 4, k plus 1. It's just a linear equation in k. Get rid of these. And 3 thrice 9. So k equals to 3 minus 1. K equals to 2. So this is the first value I was looking for. Once I have k, I can sub it back in 1. So from 1, I can do half into 2 squared plus a equals to 0, which will give me 2 plus a equals to 0. And a is a minus 2, right? So since I was running out of space, I'll solve the part B in the next slide. Part B of the same problem I was solving. Given instead a is a negative 7 over 2, find the values of k for which the line is tangent to the curve. Okay, so I need the equations from the previous part, which were the linear one, this one, and the non-linear one, which was this one. So this time they have given the value of a. So when you equate the line and the curve, this looks like 4x squared minus kx plus a 1/2 k squared equals to x negative a. So it's a plus 7 over 2. So if I standardize this equation the same way, you can pause and do it on your own. So this will look like this plus half k squared minus 7 over 2. Let's just write it k squared minus 7 divide 2. Not necessary. Whatever way you do it, just you need to solve it perfectly. Okay, so now let's apply discriminant. So this becomes b squared minus 4ac, for a, which is a 4, and c is a k squared minus 7 divide 2 equals to 0. Let's just simplify, and this will become k squared 2k plus 1. Know your algebra. Okay, so just simplification and standardizing equation. So I got a 8k squared and plus a 56 equals to 0. This becomes negative 7k squared plus a 2k and plus 57 equals to 0. I mean, this is the part where students ask, like, do we really need to show all the work? Yes. So if you check the mark schemes, you'll find a mark which is DM1. So dependent method mark. You need to show some reasonable approach. I mean, you can show completing the square method, or you can. The best I recommend for such equations is use the quadratic formula. So minus b plus minus b squared minus 4ac. A lot of you are really in good shape to apply this, so why not go with something you're good at? So over 2 and a. So I got a minus 2 plus minus. I know there is a negative 14 here. Let me just check what is the thing inside the third. Okay, so I'll be using Desmos. I'm sorry about that, but you can use your normal standard scientific calculator. Minus b and minus 7 and times the 57. Oh, that's 1600. Great. So when you square root it, you'll get a 40. So this will become minus 2 plus 40 divide negative 14. Or you can say minus 2 minus 40 divide negative 14. Let's just try to simplify these answers. So it's going to be 38 divide a negative 14. So if I do 219 to 7. So it's going to be negative 19 over 7 from here, the value of k. These are k values. And the next one is going to be negative 42 divide negative 14. Oh, 14 thrice is a 42. So the other value is 3. Let me just box the solution. Okay. So that's it for today, students, and I hope you have learned from these solved exam questions. The only way you can get better at these questions is practice. So keep practicing, know the content specification, and go over the questions. So that's the only way you'll master them and will be prepared for your actual exam. This is Global Math Mentor, over and out.